Hi, I'm Adam Simmons with Project Geospatial and the host of the Geospatial Frontier. I want to welcome you all to our Artificial Intelligence and Machine Learning panel, where I have the proud honor of introducing the moderator, Mr. Joe Victor. Mr. Joe Victor has spent the past 25 years serving the intelligence community and is currently National Geospatial Intelligence Agency's Deputy Lead for Artificial Intelligence, Automation, and Augmentation, or AAA. In this role, Joe is at the forefront of the agency's effort to employ AAA capabilities to augment traditional operations and pave the way for the enterprise's technological and cultural transformation to maintain GEOINT strategic advantage. With that, I'm going to pass the baton to our moderator, Mr. Joe Victor, as he introduces our panelists and starts the discussion.
Good afternoon. Thank you very much, Adam. I'd like to introduce our panelists. But first, let me go off and say, in addition to what Adam was saying, the biggest thing for the agency when it comes to AAA is what is our way forward when it comes to applying AI, automation, or augmentation. And by that, I mean there are a lot of efforts that the agency has and many layers of what it could mean to support our customer base for GEOINT for applying AI, automation, and augmentation. And so there are many missions that we have. And what does it mean to have a holistic approach? What is our strategy going forward? And how are we sharing that vision with our community members and our customers? And so that's the gist of what we're doing. This is a very timely and relevant topic with this panel. These are industry partners, and I'm excited to have this opportunity to sit with them and discuss some of these questions that we have, and look forward to hearing questions from the audience once we're done with the preset questions. So without further ado, I'd like to introduce Mr. Nathan Kundtz, who is the CEO of Rendered.AI. Also, Mr. Scott Herman, Black Sky Global Spaceflight Industry CTO. Dr. Ashley Antonides, I believe I said her name right. She is the Vice President of Data Science for ANNO.AI. And finally, Mr. Anthony Tellez, who is the Machine Learning Architect, Data Scientist for SPLUNK. Okay. So I'm going to go ahead and get into questions. So the first question is, commercial satellite imaging and other on-imagery commercial and open source GEOINT sources are growing in diversity and volume. What challenges and opportunities do these proliferating sources pose for AI-based analytics? So, Anthony?
Yeah, thank you for having me. So for SPLUNK, the challenge is primarily around the IT ops use case for those particular data sources. So with the need for storage primarily, right, like in your data centers, and being able to process all of this imagery that's coming from not just government satellites, but also the private industry, there's a need for the ability to store that data and then also be able to reliably use that data and provide it to contractors and internal government employees for various use cases and mission programs. And so part of Splunk's mission is being able to not just, wrangle that data and be able to do analytics on it, but also predictive capabilities around understanding what infrastructure is needed in order to scale to capacity and support those missions, whether they be on-prem or in the cloud.
Awesome, thank you. Nathan?
Yeah, well, I think we're certainly the up-and-coming organization of the group here. So I wouldn't say that we're currently facing that challenge, but what we're trying to do is bring tools to address it. And one thing that we hear over and over again is that our customers are deluged with data sources, but have a really difficult time being able to process it. So they have a lack of analysts or trained analysts to actually go through that. And that's, I think I'm speaking to where AI becomes important. So we like to help out by augmenting those data sets with synthetic or simulated data, which gives you, I think, a depth of insight into what you're seeing, allows you to do systems engineering and I think gain a deeper level of understanding about what's happening in the ground truth, but then also gain some trust in the algorithms that you're using to be able to process and perform analytics on those data sets.
Awesome, thank you. Dr. Antonides.
Hi. So yeah, I think as we're seeing kind of this explosion of new sensors and phenomenologies, there's really a lot of value in continuing to look for ways to provide sort of analysis-ready data, so to do the pre-processing so that analysts and data scientists can quickly kind of dig into some of these new sensor outputs and data sets. I think there's really been a lot of fantastic work by, for example, In-Q-Tel and XView to put out like LiDAR data sets and SAR data sets that allow data scientists and analysts to start to dig into some of those data sets. I think there's definitely an opportunity to start to expand some of that work into more multi-int type challenges and data sets that incorporate even like text and sort of unstructured data alongside some of the new sort of sensor data sets that are coming out. One of the other big opportunities that we see is really making geospatial machine learning more accessible to a broader range of end users. So not just data scientists. We're seeing kind of a push in this direction in other fields like NLP and more traditional computer vision with these sort of low code and AutoML type capabilities. And I think we're getting there with on the geospatial side, but the focus so far has been on addressing some of the challenges that are specific to geospatial data and making it easier for data scientists to work through that full pipeline of deep learning. But I think the next step is really sort of taking that to a place where end users can kind of more easily interact with some of these data sets.
Great. Scott.
Yeah, hi, everybody. Happy quarantine. So Black Sky is a global monitoring company. And while we use a lot of ML and AI techniques, I think one of the things that's really important is to not forget, kind of why you're doing it. What's the purpose of it? And, you've heard several comments, the deluge of data and how do you make it more accessible? Those are certainly important. We look at ML and AI in probably three focus areas. One is computer vision for imagery interpretation. And that's using computer vision techniques for things like object extraction, object classification, change detection. We're also using NLP, natural language processing, and we use that to pull in lots of unstructured data to give us contextual understanding of what we may be seeing in the imagery. But probably the most important thing we're working on, the most exciting thing we're working on, where I think there's a lot of opportunity and we're just at the beginning, is really around the concept of pattern of life analytics. And this does bring in the concept of how do you use multi-source observations? How do you use not only the observations themselves, but the contextual or foundational or doctrinal understanding of the objects that you're watching? This kind of facility may operate on a very different op tempo than a facility of the same type, but run by a different company or by a different country. And how do you apply ML, AI type algorithms around that level of specialization? In many cases, the question you're trying to answer with an analytic gets more and more valuable as you have a more refined, specialized question. So of course, as providers, we're all trying to juggle how do we create a general capability, but use it to answer very, very specific questions. So I think pattern of life is really the kind of the holy grail, and a lot of the techniques and methods and tools and data that we're bringing to bear around things like computer vision, the ultimate goal, and where I think you'll see a lot of effort going in the next few years, is how do you kind of move up and abstract that into pattern of life analytics?
Scott, thank you. So I have a follow-up question. I've sensed a general theme in your responses, anywhere from scale to how you access and use the data. And I'm being very generic on purpose. We tend to hear a lot of, hey, this is AI and it's going to solve your questions. You just point it at the question and it's just going to solve it. I think that might be a bit of a misnomer, right? Or maybe misunderstanding, if I can say that. And it's not because people don't understand, they may not, but it's more of it's not quite that straightforward. And so your answers have touched on that. I'd like to maybe ad-lib a little bit on this particular question and say, how do you guys envision this maybe being something that, how does an analyst or a geospatial user who's not necessarily a data scientist, and Scott, I think you touched on it a little bit, you too, Dr. Antonides, excuse me, I misspelled your name, sorry, I said your name. But how do you make it more usable to the end user, the person who's, I'm using pardon me for saying it, maybe a different capability, but I'm using Google Maps because I'm at a hotel somewhere and I want to know where the best place to get a drink and then the best place to get dinner and what that may mean depending upon where I am and the time and all that kind of stuff, especially in a quarantine situation. How do you guys make that more accessible is the gist of my question. So Scott, you're on the screen. Let's go with.
Yeah, so I'll give you one example, and it's a concept that we've been putting a lot of thought into. The gory details behind algorithms is not necessarily the key to understanding or interpreting what you're seeing. And so what we've done is we've put together a user experience around a concept of a dossier. So if you think about a particular type of facility, a nuclear reactor that's under construction, the dossier for that may include time series imagery. It may include analytic visualizations of time series data against that. It may contain the contextual information around who owns the facility, what's the workforce do, what is the timeline and schedule. It may include foundational elements like what do we know about blueprints or CAD related to that. But the idea is that you accumulate it all into a single dossier with a very easy to use web-based interface that says what my questions are is what is this facility doing? What is the pattern of life or the op tempo around that facility? And when does something unusual happen? And the dossier is a nice organizing principle for bringing together data from lots of different observational types and kind of laying them on top of each other. And that's an issue we'll get into in a little bit, is how do you get that kind of data alignment to be able to do that? And then it's just a matter of drilling in almost like a super Wikipedia around that facility, except the data is being updated as your observations are coming in from your sensor networks, from space or industrial IoT or social media and news, whatever's driving that particular piece of the dossier. We've had a lot of luck with that. It does take a lot of work. And you do have issues like, are your dossiers equally populated across the set of facilities you may be monitoring? And how much analyst intervention is required to keep those dossiers up to date? And how much of it can be automatically populated? But we find that the organizing principle there has worked pretty well. And so when we bring in AI and ML, it's about thinking of this idea of how do you feed that dossier concept, as opposed to just, here's a bunch of rasters or vectors and you figure it out.
Great. Thank you very much, Scott. Ashley, over to you.
So I would agree. I think just to build on that, a lot of our work too has been focused on the UI side and trying to develop kind of that kind of simplified workflow where an analyst or end user is probably not interested in sort of like the underlying model architecture or what data the model has been trained on, but they're coming with an intelligence question and they're saying, I want to find this in my data. And so we worked on basically almost like a search and triage interface on top of the data that lets an analyst come in and say, I'm looking for this set of objects or this kind of information. And then behind the scenes, we sort of pick the right kind of pre-trained models that are appropriate for their question and then populate those findings and then let them kind of combine the findings too. So things like color search, the NLP extraction, OCR, that kind of thing, and they can combine those results to find what they're looking for. I think in practice, the challenge is that you are losing some of that detail, where if you had that control over the models and that kind of tuning, right, there's a lot that you can do. And so it's kind of finding that balance too. And I think what we're also seeing is where we're working with interdisciplinary teams. And so it's right, where you have some data scientists and you're really also leveraging the analyst and like the SME input to validate the results and to do that kind of quality control and then feedback and provide that training data back into the models where appropriate.
Great, thank you. Nathan, over to you, please.
Yeah, thank you. So I think there's a few things that are worth kind of unpacking here. Ashley made a really good point about the importance of the user interface, but also the importance of being able to have an output that's extensible by the customer. One of the things that we've done is we're very workflow focused, and we go from data generation through data set management and then actual training. And in order to do that, we actually have sort of click through Jupyter Notebook creation. So you can just kind of click through and then create it and then download it. And that becomes your playground. So if you're not a data scientist, you can just use it as is. But if you are, or if you want to have that control, there's some really robust tools out there for that. The piece that hasn't been in the conversation yet, and I think is worth discussing, is especially with a non-data scientist user, how do they begin to trust the algorithm? And I think that that's really core to this. It's not just how do you use it, but how do you know whether or not it's actually working? And so in our minds, that's got to be an iterative process. We think that data generation and data management, understanding what's in your data, are fundamental to building that level of trust. And so we've built our workflow and kind of the user interface and the tool around being able to do that. And I think it's really important to be able to make that something that's doesn't require an expert and a level of expertise either in the data scientists or the sensors themselves, right? Because right now you almost need both before you can build that up.
Yeah, interesting. I think it depends on the sensor too, right? So what it's telling you advice, what you're looking for. So I think I'm stating the obvious there.
So that's why.
Yeah. Thank you very much. Anthony, over to you, please.
Yeah, so Splunk has taken a similar kind of approach that everyone's kind of discussed, which is workflow. That's what it really comes down to. I would say the differentiator is the persona, and I think that's what your question was getting after, is who's going to use the workflow? Is it somebody who doesn't really care about the algorithm? They just want a specific outcome like anomaly detection, or they care about doing some kind of classification or prediction or some kind of clustering analysis. They don't really care what algorithm has been selected. They just know that's the problem they're solving. And so when we look at the personas that we interact with, or that I interact with through our customers, you have differing kinds of people. Like I have SOC analysts and NOC analysts who they just want to do anomaly detection on their network infrastructure or their IT infrastructure. But then I have other class of users who are what Gartner calls the citizen data scientists, where they want to do a little bit more algorithm selection and tuning and adjustment, but they're not necessarily at the level where they want to figure out which hyperparameters do I need to activate or which layers do I need to add to a neural net. They're not going to go through a PhD program to do that. They know that they have to solve a specific problem to address whatever that business question is. And so we built assistance with this in mind, right? So I think some of the other panelists mentioned UI and the ability to kind of customize that or just select from drop-downs. That's what we've done with our machine learning toolkit. And then for the more advanced users, we built a framework on top of that called the deep learning toolkit, which allows a customer who really understands neural nets, or they love PyTorch and these distributed frameworks like Dask, or want to leverage GPUs for the accelerated model training, they can integrate Jupyter Notebook into the machine learning toolkit and do all that hyperparameter selection and build whatever custom use case they want to build, with the assumption that they understand what they're building.
Great, thank you. I appreciate you guys letting me ad-lib there a little bit. I'm going to move to question 2 now. At last year's GeoInt Symposium, talking about 2019, Dr. Lisa Porter, Deputy Undersecretary of Defense for Research and Engineering, said that conditioning, labeling, and curating appropriate training data are critical steps, but difficult and expensive. These require the right kind of tools, people, and equipment. Considering this, what are the challenges to establishing and enabling a stack for AI applications? So let's go ahead and go to Nathan, please.
All right. Well, that's a great one for us. Thanks, Joe. Of course, we promote the use of synthetic data as part of that tool set. And I think it's really important to understand that the concept is not that you kind of do pure simulations and then move directly into machine vision. But there's a lot of really interesting ways in which you can integrate simulation capabilities into that data tagging workflow. And what we've seen a lot of success with, for instance, is if you bootstrap your data labeling process with simulated data, you can actually end up with a larger data set to begin with than you started. The other thing that we have found in working with a series of customers is they often end up with data sources that are very noisy. And one of the biggest sources of noise is actually mislabeled examples. And so being able to compare the results from pure real world data to something that's been simulated allows you to kind of tease out where those noise sources are and what's leading to maybe deleterious effects in your model. Anyway, I think it's a really important problem, and I maybe would end with saying, no matter how big your data set is, there always ends up being rare cases and edge cases that you miss, and it makes it really, really hard. And in particular, often the edge cases are the pieces that are most important to detect, and they're the places where you're going to have the lowest confidence levels. And so we think that it's really important to have a strong simulation stack in parallel with those real data sources.
Nathan, thank you for that. I'm going to go ahead and go to Scott, please.
Yeah, I think the issue of labeling, massaging, preparing your data is super important, and we spend a fair amount of our budget and our resource time on things like outsourcing data to get labeling done. Right, that's a COGS, a cost of goods sold, when we think about how we're going to price our analytics services. And there's all kinds of issues related to that. How do you do quality assurance against that? How do you make sure that you've got you're accounting for statistical aberration in human labeling? What is the role of synthetics, particularly around unusual, hard to find objects, right? Finding training data full of S-400 missile sites is really hard to do. So you may have to synthesize those kind of objects. We spend, like I said, we spend a lot of our time and resources trying to figure out what we can do around labeling and what are the issues around quality, veracity, et cetera, if you do that. We've even gotten to some interesting cases about if you use foreign outsourcing, does that taint the data in its use for things like government customers, right? So there's a whole ton of different issues you can deal with there. Probably the biggest thing that we're trying to deal with around the data labeling is trying to come up with algorithms that don't require the massive sample sets of data labeling. Are there techniques we can use for semi-supervised, unsupervised learning that require smaller sample sets? We're spending a fair amount of time on that. And part of it is because, it's good science, it's a good thing to chase, but we're also trying to reduce our COGS, our cost of goods sold per analytic, and not have not only the cost of data labeling and data management, but the time incurred, right? We want to be able to react quickly. Can you chase this kind of object? Can you find these kind of things? And if it takes 3 months of data labeling exercise, you're not being very responsive. You slowly but surely build a library of analytics, but you lose that quick response capability where you really want to go in and say, I'm going to quickly have somebody find 50 examples or 100 examples and off we go, not take the time it takes to build thousands.
Great. Thank you, Scott. Ashley, over to you.
So this is also a great question for us because one of our core applications is a platform for annotating and managing training data. So we support a range of EO, SAR, FMV. We also do annotation of things like text and Street View, and actually a lot of work on like CCTV type video. One thing we sort of wrangled with is, I think oftentimes annotation is seen as a sort of offline and separate activity that you annotate the training data, create the models and then run them on your data. And I think there is an opportunity to look at ways to incorporate the annotation process directly in the analyst workflow. So how can they annotate data as they're actually going about their day-to-day job? So for example, leveraging SOM activities. Is there a way to instrument those activities or that annotation so that it also produces sort of appropriate machine learning training data? And I think the other benefit there is that then the end users can actually see the value of what they're doing in that work. They can potentially get that feedback on how the sort of labeling that they're doing actually drives model improvements. So I think that's definitely a big point that we're currently working on. I would sort of emphasize what Nathan and Scott already said, just with there are definitely techniques like active learning that we're using to help bootstrap and sort of reduce the amount of time that labelers have to spend. And then 100% that synthetics are really important in augmentation in combination with collecting real data. And then I think there are also some workflow enhancements that you can kind of bake in. So for example, with FMV annotation, we have some different techniques for interpolating between keyframes and sort of helping the analysts identify the best keyframes to annotate so they're not having to do as much really manual labor on a long video sequence. And I guess sort of final point would just be quality control workflows. And there could be a lot of time spent on QC as well. So looking for ways to reduce that QC amount of time, but also have the best sort of accurate data as possible.
Great, thank you. Anthony, over to you, please.
Yeah, so in my past life, I actually was a contractor at NGA doing some of this analysis of various satellite imagery. And as I think back on that time, I think Ashley hit on a good point, which is a lot of the workflow I did was very repetitive, and some of it was even manual labeling, but it wouldn't, it only served the good of my project. It didn't serve the greater good of everyone else. And so when you think about designing not just an ML system, but like even a data science kind of workflow, the most important thing is to capture the outputs of the analyst in a way that it's reusable and then can be and is multi-purpose. And so when we think about building things with Splunk or with any integration of another tool, that's the most important piece is like, do I want to build this thing 60 different times for 60 different use cases or projects or customers, or can I build it once in a way that makes it reusable across all 60 use cases? And the other thing is, looking at technologies that were described like the semi-supervised machine learning. So, you're not going to be able to manpower your way through all of this and hire tons of people to do labeling. It's not feasible generally, and it's cost prohibitive. So looking at technologies like semi-supervised machine learning can help. Transfer learning as well. I mean, there's tons of models that are available for computer vision that are extendable. And the explainability of some of those models are pretty well known, like if you look at the actual filters within those models.
Thank you, Anthony. There's so many tangents I want to go down with the responses. Those are excellent responses, by the way, guys. But I want to add lib briefly. So I think a consistent theme I heard in your responses was I'll say the workflow, right? And how that plays in with what the user might be doing. I don't want to just say analysts, although from my agency, obviously that's a big component of what we do. But I guess my follow-up question to that is centered on, is it more about trying to find the exquisite answer where I found the needle, or is it to narrow down where the needle might be? And I'm asking a very simple question because I want to throw that back at you, is like, because a lot of times we hear an industry, and not necessarily from anyone on this panel, but in general, we can solve that thing. I can find the needle for you, right? And I don't know that that's what the intended message is, but that's a lot of times what we hear. And I'm curious what you guys think of that. And again, that's kind of based upon your answers to the question. So, and the gist of it is it more about queuing, or is it really trying to find the needle in the haystack? What are your guys' Sorry, and Anthony, I'll stick with you since you're on screen.
Sure. So it's funny. So that's actually one of Splunk's slogans, right? It's find the needle in the haystack. I think that narrowing the search space is actually what you're getting after, right? And that's a big data question of, when I build a workflow, if I'm looking for malware, or I'm looking for some kind of IT problem, or I'm looking for fraud, or whatever that business problem is, even if it's a false positive, it's still valuable for me as an analyst to understand it and get the context of why is the algorithm telling me this, and so I can better understand and do my job. And then also provide feedback to the algorithm, right? Having that human in the loop to be able to improve the model. So I think that, getting it perfect is sure, it's what everyone desires, right? Wave the magic AI or ML wand and you get insights out of it. But the reality is, like, it's a learning process. And so if you take that learning process and you leverage, machine learning to enhance your workforce to be able to better identify those edge use cases, I think you're going to be better off in the long term.
Great, thank you. And you're welcome for the free use of your advertising slogan. I did not mean to do that. Scott, over to you.
Yeah, I think part of that question really depends on who the consumer is, right? Who the user is, who's the customer is, and what their level of sophistication is. I think providing, an analytics framework, an analytics environment for someone that has some understanding, they want you to do things like area limitation and flag on anomalies so that I, as an analyst, can go figure out what's going on. That's a very different user than someone who may be, a warfighter or a hedge fund analyst who doesn't have time or the domain expertise, the level of sophistication to go dig in and see what your analytics are kind of pointing towards. They really do need the needle or not. So I think that really depends. And there can be different models of how you build and sell and support products depending on who that user base is. The anomalies that come out of this, right? The identification of anomalies, the alerting on those anomalies can really vary depending on that particular use case. And so that drives different analytics and different expectations around things like, what is your false positive? What is your false negative rate? Or are you doing computer vision against a single image and therefore the interpretation must be near perfect or they're going to throw you under the bus? Or is it a statistical aggregation over many, many images where you're showing a trend line that says oil supplies are going up or troops seem to be moving in this direction? I think that's a big, big driver. We, for better or worse, have actually been trying to solve both of those, provide a framework for more sophisticated analysts. But at the same time, I would say the bulk of our customers really are looking at us to be a global monitoring solution. And what they want to know is as close as possible to a binary yes, no, should I do something? How does this feed into my decision process? And if you don't know, what are you going to do to find out more, which takes you down a tipping and queuing path? Can a analytic, light up a new task or a new pulse of sensors that are out there to give you more contextual understanding of what's going on to get you to the needle, even if you don't have the needle yet?
Great, thank you, Scott. Go ahead and go to Ashley.
So I would definitely agree that it really depends on the use case. If we're talking about something that's more like a process automation, then you can maybe have higher sort of expectations of what the confidence and accuracy are. But when I think about sort of like complex intelligence problems, then I do think we're talking more about kind of more of a tipping and queuing and really just reducing the search space or helping to bubble up a hypothesis or maybe something that the analysts have not thought about. And just sort of saying, here's some patterns, take a look at them. And maybe there's something that, you hadn't thought about, or just the underlying sort of processes that are taking place are just too complex for our human brains to really kind of pick up. And so you're bubbling that to the surface so somebody can go ahead and take a look at that. And so that, sort of in general, I would think that that's a sort of a safer answer instead of promising more than that. And I think a lot of that goes into talking with end users too about their tolerance for false positives, especially, and understanding what that is, but also communicating with them that there are going to be those false positives and sort of how to interpret them and how to work with them on those.
Great, thank you. Nathan, over to you.
Yeah, thanks. We usually encourage our customers to actually start with not the question of are you looking for the needle or are you looking to shrink, but like, can you even find the needle with the tools that you have available? And like, how do you start there and just say, hey, am I using the right processes? Is this question well posed? And we encourage people to sort of work through that. You contextualized this around, what the workflow should be. And like, do you have a workflow that is pointed towards, here's the needle, or do you have a workflow that's pointed towards, here's the region? And I probably would have the same, I'd speak to the same thing as everybody here, which is, of course, we're trying to make workflows that allow you to plug into our tools and address any of those use cases, right? So it's not that we're limiting people to, okay, here's an exact way that you get to your needle. There's API access to every single point along the way. And that way, if you are appreciating the workflow up to a point, you can then plug that into your other tools and work from there to address your needs.
Great, thank you all. So I think I heard you all say that it depends. in a way, right? Because it's not, I'm a king of metaphors, at least I like to think that I am. And so I don't necessarily go into fixing my leaky faucet with only a wrench, right? I have a backlog of tools, and depending on what I went into, I may actually have to cut into the wall. I may have to actually do something with the electrical. You don't know, right? And so there are many tools that you can have in your bag. And so it may not, or likely will not be just one, I think is kind of the gist of what I heard you all say. And so that opens up the opportunity across the board, right? In my opinion, anyway. So, okay. So next question. In the same keynote address, Dr. Porter also said that the DoD will require transparency into the way AI algorithms arrive at the results and should be able to replicate them. Excuse me. She underscored that we cannot abandon scientific principles and that verification and validation are essential to establish trust and confidence in AI/ML generated analyses. So the question is there a reproducibility crisis, as some have suggested, and how do we go about addressing it? So Scott, I'll start with you, please.
Yeah, so I can't pass on this question, huh? It's really it really is an issue, right? I mean, when you're talking about artificial intelligence, the idea is that you're training this engine, training this machine, but you may not understand everything that's going on inside of it. And I'm sure that people that have worked on machine learning understand that things like how do you version control an algorithm can be really hard, right? Like, is it trained enough or is it overtrained? And now it's kind of, gone off the rails and is producing results that are worse than it produced in its first few months of life, right? So those are things that we're really, I wouldn't say we're struggling with, we're wrestling with them for sure though. And that is, when do you version control an algorithm? How do you version control it? When do you know when your training is done? And then how do you prove that to somebody in terms of the results? I mean, you can certainly look at the output and treat the algorithm as a black box. If I have these inputs, the black box output should be consistent, maybe not perfectly exact every time, but they should be consistent. But you're proving that empirically, not by creating a white box or a glass box where you can go in and kind of walk your way through the algorithm, the way we did in the old days. I wouldn't say it's a crisis. I would say it's something we certainly deal with our customers when they go, why did you miss that? Or how do I know if I trust that? Or how do I offload my routine, surveillance or monitoring to your algorithm so I can get my analysts to go do things that are more interesting? But you can't miss, that routine airfield monitoring because your algorithm doesn't work anymore because it got overtrained. So I wouldn't say we've got good, fantastic answers to it. I think mostly what we've been doing is treating it as black box testing and trying to be consistent with inputs and outputs and see what kind of level of consistency we get over multiple sessions. And then dealing with that other issue I was talking about, which is at what point do you version control? How do you create an algorithm that is static enough that it's consistent for doing that kind of QA testing against? But yeah, it's a tough problem.
Yes, it is. I can tell you that. I'd love to go into this topic further, but we need to let the panelists answer. So I'm going to switch over to Ashley.
So I wouldn't call it a reproducibility crisis per se, but I do think that there is, some generalization challenges where most models are, as Scott mentioned, just trained or potentially overtrained on a specific set of data. And then when transferred to operational data, the performance tends to fall off. And then you have things like drift over time and sort of detecting when a model starts to sort of fail over time. And so I think one thing that we started to look at is, I'm not sure that it's a realistic goal to be able to build models that will generalize across all geographic contexts and use cases, but we can, I think, develop ways of sort of binning models based on things like sensor geography, seasonality, probably some of the things that Nathan looks at. And then we can say, is this model appropriate for this context? And we can start to kind of tease out and have kind of a different, almost family of models that are appropriate for different contexts. But I agree with Scott, it's definitely a challenging problem. And I think a couple other things that we look at too are just on the, I'll say sort of ML ops side too. So just when you deploy models, having that kind of built-in QA so you can start to detect when there is failure is also important. I'll just leave it at that.
Great, thank you. Anthony, over to you.
I think it depends on what your tool set is. So like if you're using some of the standard libraries, like let's say scikit-learn, the explainability of some of those algorithms is pretty easy. Like I can explain why a random forest is coming up with the classification is coming up with. But when I move to more advanced types of machine learning, like deep learning, right, the explainability of those things exponentially increases. And so when I start to think of like, how do I explain what this LSTM does? That becomes a little bit more challenging. There are libraries that exist out there to measure for like bias and try to understand like what each of the layers and each of the cells are doing. But it assumes that, again, assumes like for a data scientist, like we could look at that and we can say, yeah, I totally understand what it's doing. But for an analyst or for a government official, they're not going to be able to run that Python code and derive those insights so easily. I think one of the other challenges is, to this is if you don't have a repeatable workflow, then yes, you have a crisis in reproducibility. So one of the things that we try to do when we build any experiment within our own product is being able to keep model state. So each time I build a model, I keep a copy of that model. And I keep a copy of the input parameters and the output parameters so I can measure that over time. And why that's important is it's not just important to measure model drift, but let's say a nation state or a group decides that they're going to leverage adversarial machine learning, right, to start attacking our model and start trying to feed in data to our model in order to cause drift or in order to cause it to not be able to detect the things that it was detecting previously. So those are things that if you're not measuring them, right, and you're just kind of doing this in a Python notebook or some server and you're not actually keeping track of this stuff, it's very hard to A, reproduce it, and then B, even keep telemetry on how well your model is performing over time, and then going back to previous versions, try to understand why your model is now failing in an operationalized context for when you try to use it to a different geography or against a different target.
Great. And thank you very much, Anthony. Over to you, Nathan, please.
Yeah, thank you. I think Ashley said something which I think was really helpful here, which is that a lot of this boils down to a generalization challenge. As Scott was saying, the question is, are you overfitted? Are you overtrained? And is there a way to make sure that your algorithm is generalizable enough? Of course, there's a role for synthetic data in that, but I think what's maybe most useful to say is that if your data set that you're training on is a static entity that you have no control over, you're much more exposed to these sorts of, not just a generalization challenge, but an uncertainty as to whether or not you're able to generalize. When you start getting control over that training set and really being able to do what you want with it and have different inputs to your algorithm, that's when not only I think we find that you do a lot better with generalizability, but you also know whether or not you're generalized, because you can see whether or not it's working on different types of output, and you can understand the relationships between differences in what you're feeding your algorithm from a training standpoint and its performance under different environments.
Great, thank you very much. Thank you all for that. Given time, we're going to go over to some of the audience questions here. So I'm going to go ahead and ask this for Ashley. And then in developing ML algorithms, massive amounts of labeling is involved, and it's a tedious process. What is being done to make the workflow of labeling data easier for the end users? I think we may have touched on this before, but I think there's some still specificity in this question.
Yeah, so let me just touch on a few things. And to get into specifics, I guess it might depend. It will depend a little bit on what data you're working on, whether it's imagery and then what kind of imagery. As I mentioned, we're doing a lot of work right now with FMV data and some of the specific challenges with working on video and looking at ways to reduce basically like the number of frames that an annotator has to look at and label. So specifically there, we can actually look for kind of like important changes in the video where you would want to take a look and potentially annotate those frames, and then techniques for interpolating the annotations between keyframes. So you've made an annotation, whether it's a bounding box or polygon on one keyframe, and then you do it, say maybe like 2 seconds later in the video, and it's automatically populating that track for you. So I think, I mean, that's just one example, but some other things that the other panelists have mentioned too are things like active learning, where you can apply an initial model, or maybe you have some synthetic data that you can use to train a model and run that against your data set. And then the analyst is, or the labeler, is not having to look through the data necessarily and find the object and then create the annotation, but it's really looking for those like micro efficiencies where instead of having to do that, the labeler can just look at an existing annotation that the machine created and say, yes, no, that's correct, or it's not correct. And so I think there's a lot of these sort of small efficiencies that can be gained that, when sort of aggregated across a group of labelers and a lot of different problems, can really create a lot of time savings.
Great, thank you for that. Again, to try to make sure I'm getting some of these questions asked, I'm going to jump around. Apologies to the panel. Another question that came up, and I think I'll ask this of Scott, is what are the specific challenges that have arisen or might come up as a result of the pandemic?
Oh, because of the pandemic. Well, I mean, obviously the access to customers. We used to do a lot of kind of shoulder-to-shoulder co-piloting, with analysts and other users that gave us a lot of immediate feedback as to what was going on. So, obviously the working remote isn't ideal, but it's actually worked pretty well for us. I think in terms of other impacts of the pandemic, a lot of it just has to do with, like for example, Black Sky, probably our most important source of data, is our own constellation of sensors. We're putting up a fleet of remote, sensing, Earth observation sensors, imagery satellites, basically. And, things like the pandemic just completely disrupt, launch schedules and deployment schedules. And so I would say probably our biggest impact has just been not so much what's happening within our own company or our own development. We're actually being pretty productive in all this, but it's all the external impacts, both with our customers and our suppliers. And, nothing, there hasn't been anything, desperately bad yet. It's more just a slowdown, kind of a foot dragging, extending schedules. That's probably been the biggest thing that's been our impact from the pandemic. And just to make sure, did I answer that question correctly, or was it specifically around ML/AI against the pandemic itself?
I think it was kind of a broader term. It was. Apologies to who asked it in the audience. I read it as written, so I think there was some liberty that could have been taken with that. You certainly did address it, of course. I'd actually like to throw this back to the rest of the panel real quick. We have a couple minutes. I'd like to open that up to maybe Nathan. Do you have any thoughts on that as well? Thank you, Scott.
We were already sort of a remote company. And so for us, I was still actually commuting into an office before this, and it took about an hour off my day that I can use for spending time with my family and working. So it hasn't had a significant impact, frankly.
Thank you. Anthony, excuse me.
Yeah, so, the phrase digital transformation comes to mind. I know it's been said over the last 5 to 10 years, but there's CIOs that are our customers, right, that have had these longer term remote plans that had to be implemented overnight because of the pandemic. And so now you have lots of different access, right, external access that you normally wouldn't have on a daily basis, and trying to support other remote workers and providing them data through that pipe. So now we're talking about not just the corporate infrastructure can it handle this, but also the ISPs and everyone else who's the backbone of that network is now overloaded with the number of remote workers. So it's interesting to see how quickly things manage to change in terms of people like CIOs, like 6-month plans being implemented very quickly, whether it be in the commercial space or the federal space. But now this is the new normal, right? It's not just work from home. I think now we're in this work from anywhere paradigm as things start opening up in different states.
Thank you, Anthony. Ashley, any thoughts on that?
I don't know if you caught that. My 2-year-old just ran underneath the desk here. So,
well, that's a perfect answer, isn't it?
Yeah. But I think maybe building on what Anthony just said, I am really curious about what changes will take place as a result of the classified workforce working from home and having to work from home as a result of the pandemic. I mean, I know for me personally, one of the reasons I left the government is I was at a point where I wanted to get really back hands-on into technical work. And I'm just imagining that, or maybe hoping that this will be an opportunity for a lot of people to kind of play around with libraries and have access to tools that are maybe difficult or impossible to had been in the past difficult and impossible to work with. But I think it remains to be seen if that, what that will mean. But I'm really curious about that kind of impact.
Thanks. I will offer that from this is just me speaking personally. Our director has said, in addition to our reconstitution, that's what we're calling everybody starting to phased approach to go back to work, reimagining, right? To your point, Ashley and team, the reimagining of what it means to work. And so I don't think it's a question of whether we will or won't be doing classified from home. The question is what can you do telework, and what can you do remotely? Anywhere from professional improvement, right, and things of that nature, making yourself maybe not a data scientist, but understanding more about that and then applying it to the job you're doing. I mean, we have more than obviously a big component of our workforce is analytical or with regards to the source side of the house for data provisioning and things of that nature. But we have a huge amount of effort that also gets into your standard business type things, HR, finances, and things of that nature. So there is absolutely opportunity, and I think our lessons learned is going to help us in that regard on what we can do in this kind of environment. There is a question I want to throw to the panel. Ask for brevity here because there's one final question I'd like to address, but this is for I'll give you guys a few seconds each. Bear with me. So the question is, are all four companies currently working in NGA ? The IC, DoD, do any provide service via GSA or other GSA-like avenues to quickly gain access? So Ashley, you're still on screen. I'll go to you, and then I'll turn it over for each for a brief statement.
So yes, we are on GSA schedule, both for software and for services.
Thank you so much. Scott.
Yeah, easy question. We do work for NGA and other defense and intelligence customers, both U.S. and international, and we are on GSA schedule for both software services and for our satellite imagery.
Great, thank you, Scott. Anthony.
So it's been a while since I've been in the Fed space for sales, but we have lots of federal customers. I believe we are on the GSA schedule, and we're also in GovCloud. And we also have partners that are available to provide services.
Great, thank you. Nathan, over.
So we tend to subcontract to folks that support NGA and others, and we are working towards products that we'll offer via GSA. Okay,
great, thank you. And now one question I do want to get to, and I think I might start out and see if we have some time after. I guess I'm trying to say maybe long-winded, but hopefully not. Does NGA use AI/ML only for mission operations, (GeoInt), or are they interested in using it for corporate and business needs that can really accelerate the most difficult part of transformation? So the answer is yes. Next question. Just kidding. So there's a lot going on with that question, right? Clearly, the operations, folks think of GeoInt as pixels for the most part, right? And that's not wrong, but there's a lot behind what that means. And there's also other titles that the agency deals with, safety of navigation and things of that nature, which may not be your standard. Is this Joe in his Facebook profile picture kind of things, right? More so is this automated car going to stop at the stop sign, or is there a stop sign that it should be aware of, or things of that nature, right? So the answer is yes. one of the biggest bangs that we've seen is actually in those safety of nav missions. And I'm not going to be able to go into that too much detail, other than to say that we found some huge efficiencies leveraging some commercial resources or services, I should say, to help us automate that aspect of it. And it goes back to a point I was making earlier. It's not necessarily that I'm just going to go off and have Skynet tell me that this is the thing that I'm looking for, right? That's not necessarily what we're after. I think in a panacea world, yes, we just want to just think the question and magically the answer's there, right? We might be a couple days away from that kind of response, right? So where can you find the efficiencies and the effectivities to improve how you're doing your business, if you think of it in that regard? And then maybe that allows you to then reinvest or spend more time on doing other things with those resources that you're freeing up. It's not that we're going to have a magic amount of new resource to deal with, but maybe we can free up our resource to do more and automate some of those mundane things. And so that is a huge piece of it. And I think the last part of the question was can really accelerate the most difficult part of transformations. I think trying to address those things that make sense, that may be more mundane and more automatable, or if I can call it that, or things that take the mundaneness out of doing stuff, absolutely then helps you free up and attack some more of the difficult challenges in that regard. So, okay, so I think we're about out of time. We have about 3 minutes or so left. First off, I'd really like to thank each of our panelists. You guys have done a phenomenal job. I appreciate you bearing with me and kind of the slight tangents, but I wanted to dig in a couple of the responses to the questions that we had. I thought that was really valuable that each of you had that opportunity. So real quick, any closing thoughts from the panelists I'd like to share? Nathan, you're on screen.
Joe, it's just a really pleasure to be here, and likewise, I thought you did a great job managing the panel. It's a big topic.
Well, thank you for that. Ashley, over to you.
Likewise, thanks so much for the opportunity to be here. It was great talking with you all.
Scott?
Thanks for the invitation. It's a lot of really interesting topics, kind of live and breathe this stuff. Just one quick go back, and it kind of goes to the transformation and also the working from home. While we're talking a lot about ML and AI, and it's about algorithms and tools, as we work with agencies that are trying to figure out how to deal with COVID and work from home, that's not where most of the issues are. The issues are around tradecraft, it's around OPSEC, it's around publishing and dissemination of the results they come up with. It is a little bit about the tools, but it's even more so about what is the unclassified data sources that they can use. And kind of the final topic there is, and after you've published and disseminated unclassified, how do you get that back to the high side where you can mix and mingle it and keep it for posterity? So just a little bit of a go back there. The algorithms and tools are important. And I think there's a lot you get access to working on classified that you normally don't get on the high side yet, but there's all these other issues you have to figure out in order for working from home or working in the open to be successful for those type of customers and use cases.
Great, thank you. Anthony, over to you.
Yeah, I'd just like to thank you for the invitation, and I'm happy to join another panel if there's a round 2 of discussion on AI and machine learning at NGA.
Great, thank you. I certainly hope there will be that as well. And Scott, thank you for that amplification, by the way, about the pandemic piece. So I just want to again thank you all for those that are listening, for the panel that was so kind with me asking questions of you, and especially to the Geospatial Frontier and Adam for facilitating that for us. With that, I think we're almost right at time. And so thank you all very, very much.